Hi, good morning. My name is Gilberto Estrada Cerón, and today I will show you the research title Mechanical Properties of Polymeric Multiphase Structures, the Impact of Configuration and Printing Design. Currently, additive manufacturing has become a widely used technology to manufacture prototypes and functional parts. However, one of the most important challenges is to achieve part with reliable mechanical properties because they depend on multiple factors such as the type of material, the infill pattern, density, and printing parameters. In this research, we focus on evaluating how different polymers affect their mechanical performance, taking combination of that of stranger and more durable parts. Introduction. As an introduction, the main focus of this research is porosity. The analysis of mechanical behavior of multiphase polymers, multiphase the additive manufacturing, focuses on analyzing the behavior of each material under the same load or stress condition, changing the orientation and proportion of them in a single structure, in which they intertwine with the other materials, yielding a proportion of the unique properties of the rest for the materials. The general objective is manufacture and evaluate multiphase polymeric structures. A specific objective characterizes material um, characterizes the physical properties of the material used, considering factors such as density, composition, and compatibility between phases, analyzing print parameters that influence the mechanical behavior of multiphase structures, such as the printing orientation and the configuration of the polymers. Um, Perform tensile and impact mechanical tests to evaluate strength, sniff, and energy absorption capacity test ISTM test methods, analysis and correlate the parameters of the mechanical properties of multiphase structure for their better and greater utilization. Context and problem at stake. The limitation of traditional manufacturing for biomedical polymer structures, um, as is well now, traditional manufacturing has present limitation in producing complex biomimetical polymeric structures, since when using the traditional material subtraction method, it levels weak space that as they progress can increase fragility and it becomes almost impossible. In addition to the fact that currently there's limited information about the mechanical performance of multiphase polymers to AM. Furthermore, another important factor is the variation in printing parameters. They make repeatability and reliability of the parts difficult. For this reason, the study seeks to compare the performance between multiphase polymers under controlled conditions. PLA and multiphase polymers. Polymers as a basic concept about polymers and the material specifically used in the research, we know that polymers are molecules composed of the repetition of simple chemical units called monomers. PLA is part of the test as polymers. They are homopolymer since it is formed with the repetition of a single type of monomer, lactic acid, or its cycle form lactide, which gave it homogeneous property and potential such as biodegradability and sniffness, being a biodegradable and widely used polymers. Multiphase polymers are materials composed of two or more different phases that are related. The phase can be formed via physical combination or different polymers that combination of aid parents, such as nanoparticle fibers or additives, or by the formation of fast separation microstructure indexed during the process. They stand out today advantage in terms of stiffness and strength. PLA with carbon fiber, with its excellent mechanical properties, low density, resistance to corrosion, work at the permanent conductive low thermal expansion. PLA with polyhydroxyalkanatus, bioplastics intersect Dr. biotechnology, and biodegradable and natural products by bacteria, has the advance of resistance to moisture and oxidation. Additive manufacturing and its technology advance has manufacturing a method 3D print (FDM) fused depositing modeling was used, which consists of using a thermoplastic filament which is controlled via pair of lots screw responsible for depositing or retracting the filament. The melted tugged at temperature regular and extruded to a nozzle in the front of thin thread. These thermoplastic tears solidify as they take the shape of the design layer by layer until complete the required model. For the manufacture of ASTM specimens, a bamboo latex one carbon print was used, which the printing is carried out, allowing work with up to four materials of color thanks to IMS. As critical technical parameters, which are extrude temperature, heated bed, infrared percentage, layer height, and infill pattern, a standard parameter was used for the four elements because they directly influence the quality and final properties of parts. Design and experimental development. The design and organization strength of the specimen based on ASTM standard for durability and compatibility used in mechanical tests were designed in SolidWorks student bench, where a standardized specimen was designed at the fast section. As observed below, the specimens were designed with two different cores. The first with a square core, which provides better stability and pressure between printing lines, and the cylindrical core, which provides better mechanical strength due to absence of vertices and reduction of stress concentrations. Um, Tensile test results. After having obtained a right printing specimen, we proceed to carry to tension test, where the table with the average of the deformation are is shown, where the mechanical properties of the specimen were analyzed in relation to trade standard deviation of the experimental work carried out in the testing machine. Thus, the table is made up of the values and their average of each tension test summation to study into only third value values. The graphs show the results of the tension test performed on the three types of structures: the simple multiface sample, the multiface with cylindrical core, and the multiface with square core. In the tensile stranger, simple multiface structures show the highest tensile strength, approximately 42.69 MPa, with the structures with cores show slightly lower values, approximately 42.11 and 42.1 MPa. Yellow strength. The simple multifaceted structure also has the highest yield strength, 2.194 GPa, while the structure with the cores have slightly low values, approximately 2.155 and 144 GPa. Elongation to simple multiphase structures present the grade elongation approximately 4.2%, while the cylindrical and square core structure show the reduction ductility. This means, this means that the addition of course slightly reduce the mechanical strength and elongation which indicate. In this slide, the same microscopic results of the specimen after the tensile test are shown which allow observing the microstructure and possible defects or relevant feature of the printing piece. The images are organized into three columns. Columns left, a section with cylindrical core. Central column is a section with square core, and the next is four section with core, without core. Each, mm, in each column has two rows of images. Top rows is 15x magnification, where the complete fracture of the specimens can be observed. Here it is saying how the materials separate and the difference in the cross affect the tensile test. Bottom row is 500x magnification, focusing specifically on the core of the specimen. In thus imagine the union between PLA-PH8 and PLA-CF polymers, the separation of the materials, the printing lines, and the interlacing between layers can be seen. This micrography allows us to visually compare how the geometry of the core and the printing parameters affect the fracture and the integration of the materials in the multifaceted structures. Um, Multiphase polymers show conclusion and recommendation. Finality, the main conclusion of the researchers summarized, highlighting that multiphase polymers show better mechanical performance than single-phase ones. Multiphase polymers show greater mechanical resistance than monophase. PLA with carbon fiber have the highest elastic modulus and tensile strength. Um, Printing orientation, speed, and core design significantly influence the results. Core design, core design improved stress distribution and reduces fracture points. Combination fast notability involves mechanical properties, printing parameters, and integral geometry are critical optimization, efficiency, and performance of structures. Potential for application in lightweight and resistant structures. The results obtained confirm the results obtained confirmed that multi-phase configuration of polymer materials, when correctly designed, can significantly improve the mechanical properties of a structure, showing that the stress-strain properties of the simple multiphase structure are low that those of the multiphase structure with a core would have to take. This is because when generating a multiphase structure with a core, an inverted two-phase matrix is being designed, giving it the same properties of age of that polymer of the polymeric material that make up both phase, but the internal on which is the core, and the external on which is the shell. Thanks to Dr. Mariana Vega for the pics of the sim. Thank you for your time.